last time we discussed many introductory topics. So let's do a quick recap and then we'll begin with the content of our session. So today we'll be covering system design of TinyURL, and then we'll be also covering this interview problem. It's a very common interview problem, which is a system design interview problem, and we'll be covering this. We'll be also covering a lot of concepts, which are basic concepts for system design. See, if you attend these classes sincerely, then definitely I can guarantee that you will have a very good understanding of system design and will be solving so many problems that you will become expert in system design. And in any interview, you will be able to easily crack it, right? So this entire series of lectures, which I will be taking, is based on system design. Last time, I'm recapping what all we covered last time. So I want answers from you. Who will tell what is system design, right? Anyone having any idea what is system design? Because it's very important we understand why we have system design interview and what is system design. No one is able to tell what is system design. Okay, Shahjahan, you want to say?
Yeah, actually, I have a basic understanding of system design.
Yes.
Yes, so basically system design means like we are designing a system end to end, and we are like architecting, and like we basically create an outlook like how it will work and how exactly like what things we are going to do, what technologies. Yeah.
Yes.
So
right. But yes, what is a system actually? In this case, what are the different kinds of system we encounter in our real life? Right. So here you see two terms. One is system, other term is design, right? So what is a system? Design, we understand. Design is the architecture. So here, when we say design, we mean architecture and design, right? So this is the job of an architect to design any system. Great. So what is a system? Right? Basically, we encountered a lot of systems in our day-to-day life while using computers, right? So systems could be a lot of applications. We use so many applications, right? Currently, we are having video conferencing. So you have Zoom or Google Meet. These are also systems. We use YouTube. We use WhatsApp. We use YouTube. We use Facebook. We use Gmail, Google Docs. Give me more examples of such systems. Who will give? Typing. Okay. Yes, I see some typing. Okay. Yes, great. I see Instagram. Okay, nice. Great. Hotstar. Okay. And then, okay, yeah, this is any system. So now, yeah, Netflix and a lot of systems, Sony Live and lot many other similar. What else? Yes. Okay, Book My Show. You guys are giving good examples of interview questions, right? So yeah, this is Amazon Prime is also like Hotstar. Yes. Okay. Then you have systems like Swiggy, Zomato. Okay. Yes. And system like LearnBay. Okay. I understood this. But yes, I'm just not putting it. Uber and Ola. Okay. Right. So these are other examples of system. Airbnb. Right. You guys are able to see this font size is okay, or shall I increase? Let me try increasing this font size. Yes, slightly. I'll move this around here. And now this is better for you, I guess. Yes. So yes, perfect. So you see so many questions, so many different systems are there. Each of systems are very different from each other. And we will be covering many of these systems in our system design, right? Absolutely. ChatGPT is also another kind of systems. Now, these systems are also distributed system, right? So we will cover what is distributed systems. But before that, you know this, now we know so many interview problems, right? Now, design or architecture, this is of two types. Yeah. What are the two types of design and architecture, which is generally asked in interviews? Just give me the answer, because I want you guys to answer. We'll have kind of a brainstorming group exercise throughout. In interviews, you guys have to answer, right? So a design could be of two types, or system design interviews can be of two types. Yes, absolutely right. So I see from Bajrangi answer that this is either high level design, right? And low level design, right? Good. So this is the two types of design, high level design and low level design. For both of these interviews, what are the goal? See, all the big tech companies, they have system design interviews. Goal of these interviews is to test your which skills? Right? This is skill. And skill to architect a system, right? So this is called software architecture, right? Now, I will be listing all these skills. Pay attention, because these are the topics you may try to recap. See, listen carefully. So these are operating system, networking, yes, databases, right? So database, or you have DBMS, right? And then what else can be required? So see here, operating system, I mean operating system or OS, networking, databases, right? So distributed computing or distributed systems, right? So you know, you need to know software architecture. Software architecture also involves a lot of concepts: object-oriented programming, data structures, and then you have design patterns, right? And then I will also cover in later classes a lot of low level design concepts, which is solid principles, Yagni principles, and there are few more principles, which is about writing clean code, right? We'll be covering that. So these are the computer science skills you should understand, right? Now let's start working on the skills, right? But yes, other than this, system design interviews will also cover your communication skills. So that's why I'm giving you opportunity to communicate, speak, because communication skills very important. They are also important for communicating any architecture and design, right? Yes, we will be covering microservices design pattern as well, but have patience. We will be going from fundamentals to very advanced topics. We will be covering everything related to system design interviews. You can also suggest topics if you want. And I have myself cleared various interviews. So listen and also follow my approach. I have cleared Google interviews. I have cleared Microsoft interviews in system design. So the way I am teaching, follow my approach and see how I am approaching any problem and how I am prescribing to solve any problem. and I'm covering fundamentals also, because understanding of fundamentals is very important, because you may get these questions which we just listed here, or you may get a new question, totally new question. But if you have good fundamentals, then you will be able to design anything, right? So do not worry about a specific question, worry about the approach, worry about the concepts. Great, awesome. And wherever you have questions, feel free to post it in the chat, or you can feel free to ask it, right? So let's start with what is distributed computing. Let me put this at the top. Let's talk what is a distributed system. Who can tell me what is a distributed system, right? So we will be designing today a system which is called TinyURL. Okay, you guys have missed it. You don't tell. This is also a system we will be designing today. This is a very important question, is the basic question, and it can be asked to people with less experience, and also it can be asked to people with high experience, with too many years of experience. So now, before we pitch into the topic, I want to cover one concept, which is what is a distributed system. Now, distributed system means, I will share you what is the distributed system. Distributed, you can have a collection of systems, right? So in distributed system, what does it mean? It means that there are multiple independent computers or nodes that work together as a single coherent unit, right? So if you have many nodes, let me show you. Yeah, you have one server here, one server here, and if they are working together, they are connected, and they perform some application, they execute some commands, then this is a distributed system, right? Now, to be a distributed system, systems must be independent. They should be performing a single operation, right? And there should be communication between them. And what are the advantage of distributed systems? I'm putting here. Why do we need distributed system? Anyone? Why we can just use single application, a single server? Can we use single server to run all these applications or to build these applications? Can we use a single computer? Okay, great, awesome. Yes, one answer I got. Basically, you see, good. See, until unless you don't think, you will not get the answers, right? Okay, very good, very good. I'm seeing some answers, because the more you think, more you participate, more you get better at an interview. In the interview, you will be able to answer, right? See, if there are large number of requests, assume, let's build one application. Let's say we are building one website with single computer, right? So the problem with this is large number of users, if they are visiting, it will not be scalable. So very important thing is your system should be scalable. Yes. Great. Then what else? Single point of failure. This is also a good point, that there should not be any single point of failures, right? And then what else? You can do resource sharing, right? So SPOF, you should know the full form of this, single point of failure, right? Okay. Scalability and single point of failure, these are two different things. You mentioned it. What else? Think about more items, more characteristics, which is important. What if we have only one system, and if that crashes, what will happen? Okay, concurrent access. This is another advantage I see. More people can access without hang off application, yes. But yes, see, very fundamental things. You should know this, because otherwise you are missing out. You will not be able to do good system design. Very important thing is availability. You should understand what is availability. If you are hosting one site in one computer and it crashes, some hardware failures happen, your site will not be available. But if you have two or more computers, one goes down, your site will still be available. So there is availability, right? High availability, yes, good. So that's one example. You can have more availability with distributed system. You can have better performance with distributed system, because you are running some algorithm. You can process some part of data in one computer, process another part of data in another computer. So this way, concurrently, you can process large amount of data. So there is performance also, right? Understood? So availability, scalability also, because you have multiple systems, you can use a load balancer and distribute the load into multiple systems, right? So let me put a load balancer here also, right? So let me call it LB, right? So if I put a load balancer, I can distribute the traffic into these servers, right? Two servers. And these are the request which is coming from user. So here you have user request, right? And then if the request come, you can distribute between two nodes. Either this call can go here or this call can go here, right? Now, this connection is not very much necessary. Communication should be there, right? So there could be communication, yes. And there could be communication through database also, right? So here you have the database as well. So with database, you can get some communication also, right? So both are, if updating information, reading, writing from the same database, then this also, they are both in sync, right? So this is how you can load balance and have more scalability. What else? There is something called fault tolerance, right? Fault tolerance means if both these systems are located in different parts, right, then there is fault tolerance, because if one operation fails, right? So if you're performing multiple operations, one operation fails, single point of failure is not there. So you have fault tolerance as well, right? Durability, reliability. Yes, this is what you mean there. Perfect. So you guys have explained fault tolerance is about durability, right? And definitely you get parallelism. I also mentioned this, that this is high performing, right? And it is also cost effective, right? You should understand that distributed systems are cost effective, and because buying a single server which is very high performing is very costly. But if you buy small servers and have multiple computers, then this will save your cost, because you can use some existing servers as well, put them in a distributed environment, and then you can get high performance rather than buying a very expensive server. So these are some of the benefits of distributed systems. But now we understood what are the benefits, but let's look into what exactly are different types of distributed systems, right? Another point I would like to mention, distributed systems are more secure, right? So they have security as well. So these are various advantages of distributed system. Why they are secure? Because there is no single point of failure. Yeah, Arun, you have a doubt? Go ahead, ask.
Yeah, hi. I have a doubt. When the distributed systems are scalable, right? And
Yes.
if they are scalable, then automatically it will be high available and high performance, right? So like So the scalability inherently giving the high availability and
necessary.
okay.
Not necessary, right? Correct? See, there are a lot of systems. Scalable means many number of users can be a system can. So I'll tell you, scalability means there could be many users, right? But maybe the user request are it's taking too much of time to process. You might have seen many sites are very slow. They may take up thousands of users, millions of users, but still it could be slow. So performance is another characteristics. Scalability is another characteristics. Availability. Maybe you have a very high performing site, right? But it is not available. That can also happen, right? So it's down, but yeah, when it comes up, maybe it is high performing, highly scalable, but it crashes too often, right? So it becomes down. Then it is less available application, right? So these are all different characteristics. A system could be scalable, but it may not be performing, right? Or it can be also low available. It could be scalable, or it could be highly available, but not scalable. Or it could be highly available and non-performing, slow, right? So these characteristics are all separate. Clear, Ramesh or Arun?
Yeah, clear.
Correct. Now, yes, again, security is another characteristics. A system can be secure or unsecure. It could be scalable, available, performing also. But system could be secure or less secure. Now, why distributed systems are more secure? Because data is also distributed in multiple systems. So it is not easy to hack it, because you have to hack multiple systems to get the data, to break into it, right? But yes, security needs this special consideration. But yes, you can achieve high security. By default, it does not comes. But if you plan it properly and design the system properly, system can become more secure. If you plan in a single computer system, security, it is not that secure, but a distributed system will be more secure. We'll cover this. You will understand all these points. But yes, it's very important to understand all these non-functional requirements or system characteristics, because all the system design questions will be based on this, and you have to understand them very thoroughly. Right. So yes, database can become single point of failure, right? Definitely. But when you say database comes in cluster. So usually for all highly scalable application, you'll not have single database instance. You will have multiple databases or database. There will be cluster of database, right? So there will be different kinds of architectures. We'll learn master slave architecture and multi-master architecture, how you can achieve performance of database, how you can achieve more performance as well as availability, reliability of databases, right? So yes, definitely databases needs to be backed up. We'll cover all that slowly and gradually. But yes, I am focusing on what is distributed system. We will cover, yes, multi-tenancy is another characteristics which also does not come by default, but you have to design it. But yes, we are focusing on fundamentals, right? Now, these are the advantages. There are some disadvantages as well. So I'll put some disadvantages also, right? So here we have advantages. Some disadvantages of systems are error handling is difficult, right? In distributed system. What else? See, management of system is also difficult, right? Management, monitoring of system is also difficult because you have multiple systems which are distributed in multiple locations. These systems need not have to be located nearby. They can be located in different parts of the world, right? Yes, setup is different. Yeah, difficult. Definitely. That's why management. There could be replication problem, right? So if you have a distributed system, if you have to copy the data, use the same data across all the servers, then you need time to replicate. You may need to replicate the data, right? Replication is required. So these are some of the drawbacks, right? But we will cover them again in detail. But let me take you to some more topic, which is related and which is fundamental topics. Let's talk about different kinds of distributed system, right? You have used and seen many, but you may not be knowing, right? Yes, Bajrangi, what is overloaded? Are you feeling overloaded with all these information, or you are talking about system? Anyone feeling overloaded with a lot of information, right? So yeah, a single system can become overloaded, but if you have multiple servers, then this is not overloaded. Okay. Now let's talk about, but yes, I will cover and we will be dealing with all the distributed systems. So don't worry, you will master the concept of distributed systems, right? So let's talk about, there are many problems in distributed system. We will cover various problems in distributed system also, but don't worry. But let's talk about what are different kinds of distributed system. You would have known a lot of distributed systems, right? Okay. How many of you know about this one? Client server architecture, right? Client server architecture. Anyone? Can anyone explain what is client server architecture? No one knows client server architecture?
Basically, in the client, we have a front end, maybe like a front end for like,
Okay.
like Angular or a React or somewhere. And in the back end, we have APIs that's been exposed to the front end with the protocols like REST or what do you say, a UDP protocol or something like that.
Yes.
So,
Yes.
and socket
Right.
program.
Correct.
So,
See, client server computer is just something like this, right? You see here, you have clients, you have a server. Now, how the client communicate? Server may be doing some processing. Server is a system which has some processing power. Clients could be having some less memory, right? Or less processing power. And they may communicate using some UI, which could be web UI. They may also communicate using command line interface, right? You people understand what is command line interface? Like in the terminal window, command line, you can execute some command, you can connect to the server and get some commands executed, right? So this is client server architecture. This is for one kind of system, right? There are other kinds of system also, which is you guys have used. Anyone, you would have seen a lot of systems, various kinds of this systems, peer-to-peer networks, right? Have you seen this peer-to-peer networks? Any examples of these systems, you know? Yeah, torrent, BitTorrent or file sharing system, peer-to-peer networks, also distributed system. Then there is something called cloud, right? These are also distributed systems, right? So for example, AWS, Google Cloud, whatever cloud applications you are using, these are also distributed systems. And then there is something called grid computing, right? Grid computing is also distributed system, right? So grid computing you can thought of is something similar to cryptocurrency or Bitcoin, right? When some processing is happening in multiple systems. So this is about grid computing, right? So these are different kinds of distributed systems. In your office, you may be sharing printer, right? So printer sharing can also happen. Basically, these are all networks, right? There are different kinds of distributed system. So you can share resources across multiple systems using distributed computing, right? So this is just enough for now to understand distributed systems. Now, next thing which I will be teaching you is we will be focusing on three things, three different characteristics, right? So these are the three important characteristics. Okay, so yeah, I will make it a little bit bigger so that you understand. And so yes, let's talk about what is consistency. Yes, what is consistency? Assume we have this setup, client server architecture, right? Or let's have some simple setup where you have two servers, right? Okay, one example I will say is, let's say you have any application, which could be say Zomato, Swiggy, or it could be Domino's or any other application. Assume you place an order using a mobile, right? So when you place an order using mobile, there will be multiple servers which will be serving the request, right? So let me draw that also. Here you have various servers. So you know, you guys know this architecture very well, that yes, you have various servers. Okay, maybe, yeah, these servers could be in different locations also. And then you have the databases also here. Okay, okay, yes, okay. Let's say these are the databases. Then you have a load balancer also. And then you have clients here, one client and another client, right? So let's call one client as, this is web UI. And then the other client, let's call this mobile app, right? Yes. So when you make a request, call goes to load balancer. This is load balancer. And load balancer routes the request to different systems. Right? Let's say this system is system 1. This system is system 2. This system is system 3. Right? See, diagramming is very important. You can do the sketching also with me, because in real interviews, you have to draw these diagrams like this in the real time. First you are, then it's better because you will be able to explain the architecture. So try drawing the diagram by yourself. You can use any tool, whichever you are comfortable with, but you can use pen and paper. That is the easiest. So use pen and paper. Then I'll also share about various tools which you can use for diagramming. But see, keep thinking when I'm teaching and keep participating also, right? So here someone makes a call, makes a order, right? You ordered a pizza, say using mobile app. Now your mobile go out of battery. Yes. Now what you do, you open your laptop, you log in, you check what is the status of order. Assume you have ordered some pizza, right? Maybe some pizza you have ordered, veg extravaganza or something. Yeah. Okay. You guys are feeling hungry? No, don't feel hungry. This is just an example. But yes, if you go through web UI and see if your order is not there, is this consistency or not consistency? Right? So the consistency means if you are using different clients, or if your request is going through different servers, still it should fetch the same data. It should be consistent, right? So it may happen that, okay, web UI is served using system 1, mobile UI is served using system 2, servers 2, but there should be sync between all the databases, right? If the sync is not there, then there will be inconsistency, right? So this is important, that in our distributed systems, there should be consistency. Otherwise, you may not get the data. So you may see that, okay, in the mobile, it's showing your order, but in web UI, you are not seeing the order, which is a bad experience. So very important, our distributed system should be consistent, right? Now, next, another example, availability. Availability is another, I'll give an example. You ordered the pizza. Now you are seeing what is the status, whether it's baked or is it in the delivery stage, or right. But yes, after you ordered, you paid and you did not got the order and the website goes down, right? Again, bad experience. So if website is going down, that is availability issue, right? The website should be available all the time. And if a website is down, it is a business problem for the company also. People will not be able to order pizzas and Domino's will be losing money because a lot of orders it will not be getting. So this is about availability problem. Now, third thing is partitioning or partition tolerance. This is also known as tolerance, partitioning tolerance, right? See, what is it? I'll explain you. This is also important concept. What is partition tolerance? Let me try moving it in the same line. Yes. See, partition tolerance is maybe this connection breaks, right? Assume this connection breaks. Will you be able to see the application running, right? So if between the servers, the connection breaks and still the application is running, it is called partition tolerant application, right? So this is about partition tolerance. So assume if this breaks, what will happen? If you ordered some pizza and that information is not available in other, then you will not get the consistent information. The order will not be there, right? Or if you change the pizza order, you change some topping, if they suppose allow you to change the order after you have ordered, then you will see the change in one place, you will not see the change in other place. So that will become a consistency issue, right? Or if application goes down, then this is availability issue, right? So now let's talk about the most important theorem or most important concept in system design interview. So this is called CAP theorem. I am putting the term here in this is called CAP theorem. Can anyone explain this? Yes. What is CAP theorem? Anyone knows about it? Because if you don't know this, then you will definitely struggle. You will not be able to solve any of the system design problem, because this theorem has to be applied in all the system design problem. Like you need to understand for data structures, time complexity, space complexity. In the same way, CAP theorem you need to understand, right? So now let me share you what is CAP theorem. CAP theorem says in any distributed system, you can achieve only 2 of the 3 characteristics. And CAP stands for this what? C stands for consistency, A stands for availability, P stands for partition tolerance, right? So the CAP theorem says you cannot get all 3 in the system. You can get only consistency, availability, or partition. Only 2 of these characteristics, right? So let me show you in a diagram here, right? See, this is the diagram which explains gap theorem, right? It says consistency is all the clients see the same view of data, even right after update or deletion, right? This is consistency. Availability, are you all able to read? Okay, I have made it bigger. All clients can find a replica of data, even in case of partial node failures, right? See, availability could be there, but consistency may not be there. So you should also understand, we were discussing that, yes, you have availability, scalability, performance, and a lot of other things. Everything is independent of each other. You may have the application running, but you may not be seeing the consistent data. Sometimes you are making a call, you are seeing some data. Sometimes else you are making the call, you are seeing some other data. So the application is available, but it is not consistent. I will give you a real life example. In Facebook, when you make a new post, all your friends do not see it immediately, right? In any application, if you update your profile pic, everyone will not see it immediately. It will take some time. So maybe some users will see your old profile pic, but at the same time, some users may see your new profile pic, right? So this will happen. But yes, after a few hours or after a few minutes, it will be updated. But for some time, there is loss of consistency. But yes, application is highly available. Facebook is available all the time. You can go and visit, send messages to your friends, like and share any photographs anytime. But yes, it is not consistent. There could be time where some data is inconsistent. Same happens with comments also, likes also. When you like, maybe all of the users may not be seeing. Some users are saying, okay, there are 5 likes. Some users are seeing, okay, there are 6 likes. Or some updates, some comments will be visible to someone, some comments may not be visible. So such kind of systems are non-consistent, inconsistent systems, right? Now let's talk about partitioning. System continues to work as expected, even in presence of network failure, right? So this is partition tolerance. So you can get not all 3 of them. See here, there is a cross in this. It's kind of a Venn diagram, right? So a system cannot have all the 3 characteristics together. It can have only 2 of the 3 characteristics. Yes. Okay, let me explain you partitioning in another way. So assume you opened the pizza shop. We'll give another pizza example, right? But yes, you started, assume you are taking the orders. Initially, it's your startup. Initially, you are taking the order on phone, right? So yes, whenever someone wants to order, they will call you. And then you take the order and take the address and deliver it, right? This is good, highly available application. You are sitting in the phone, near the phone all the time. So your pizza ordering system is highly available. Understood? Is it scalable? How can you make it scalable? But yes, since you have only one number, mobile number, the application is not scalable, because if one order is coming, by the time you are taking one order, you are not able to take another order, right? So this is available, but not scalable. To make it scalable, you will get multiple mobile phones and maybe multiple people to take the call. Maybe you invite your friend, you employ your one friend, and now you have 2 phones and 2 people. Both of you can take the orders, right? Now, some orders comes to you some order comes to your friend, right? But yes, when someone is asking for a status, he may call any of the number for the status of the pizza delivery, right? So you need to be consistent. That means you and your friend should know what all orders have come. After they take the order, you should share it, right? You should communicate with each other and share that, yes, this order has come and this is under processing, right? But yes, what if you don't talk with each other? That is, partition has happened, right? This is the case where this is called partitioning. Now, maybe reason is your friend went for some work, right? He took some order. He did not share you that these orders are taken, and he went for some work. Maybe he went for having lunch, right? So in that duration, if you are getting calls for what is the status of order, you'll not be able to tell because you don't know what orders have come, right? So this is called partitioning. When two servers cannot replicate information with each other, this is partitioning. But yes, you are still taking orders and you are also processing the orders, right? So system is available, system is scalable, system is not consistent because the information about his order is not available with you, right? If someone calls that friend, he will tell you the order number, even assume he has taken the mobile phone while having lunch also, but he's not close by. But yes, what you can do is you can communicate with each other, and in that case, you can answer all the information. So here now you see how you can make this system. So here your friend is also taking the orders during lunch to make it available, but it is not consistent and it is partition tolerant because even if you both are not talking, you are able to take the order, system is available, but yes, you are not sharing the information. Other case could be, you can say, until unless I talk to this guy, I'll not share you about the status, right? The status of the call. So you may say, no, I will not talk about the status until I'm synced with my friend. So this is what you have done is you have restricted the availability, but you have now consistency, right? Because anytime people are accessing the data, they will be getting consistent data. Yeah, because you are saying, okay, till I talk to this guy, then only I'll be able to respond. So I guess now you guys understand what is partitioning and what is consistency, availability, all three, and what is CAP theorem. Right? How many of you got it? Say yes. How many of you did not got it?
Yeah, I have a few doubts.
Go ahead.
Yeah, in case of consistent, let's say there are two servers, server 1 and server 2, and we are writing to server 1 and it is
Yes.
syncing to server 2, and then only it can take the new request. But during this time, it is also available and right, it's also
Yes.
available.
Yes, yes.
But at this point of time, then we are having consistency, availability, and partition tolerance, right?
Yes. Right.
We
See,
are having three.
I'll tell you again.
Yeah.
See, what happens in net banking? This used to happen earlier. They say, okay, they make the system available by having too many parallel systems, right? So, but yes, when the data is synced between multiple systems, this is application is down for maintenance, right? So this is how they ensure availability. Come again with your question, how you are saying all three is possible?
Yeah, that is in case of like if something goes wrong, I mean,
Yes.
okay, I will repeat the question again.
Yes.
We have two servers, server 1 and server 2.
Yes.
And I sent a write request to server 1,
Yes.
and yeah, it should be strongly consistent. So it will sync the data to server 2, and then only it will uh, take the request.
Okay. Yes. Yes. Right.
Yeah, so at this point of time, when a new call comes during the sync, that call will be unavailable. Is that the case?
Yeah. See here, partition tolerance means, right? If this connection breaks, you will not have consistency. Got it?
Yeah.
Right?
Yeah.
If this connection is there, no problem. Yes, you have, but yes, when this connection breaks, so what you can do is, if you still keep both the systems available, right? So that means you have the load balancer and you are serving request either from server 1 or server 2, right? So if this connection breaks, this is what partitioning has happened, right? Without this, no problem. Then you will have no consistency, availability, but there is no partitioning here. There is connection, right? Because network failure is not there, right? So
Okay.
2 is there.
So you
Connect.
mean, okay, in partitioning means if the connection
Yes.
breaks.
Yes, this connection breaks, right? It can
Okay.
happen, right? Maybe that time network is down or some error has happened and sync could not successfully happen, right?
Got
So
it.
in this case, you have two choices. Either you make it down and you just take the request only once the sync is successful. Correct?
Yeah.
So then you are compromising on availability, which you were also mentioning. Yeah, by the time the sync happens, that means there is unavailability because you are keeping the call on wait till sync is happening, right? But if you want consistency, you have to compromise on availability because you have to reattempt the sync and do not allow any read and write for this application. Yes.
Yeah.
But yeah, if you want availability, then you can compromise on the consistency. So that is what Facebook does. Facebook, if you upload the photograph, they don't bother because this photograph is not that important thing, profile photograph. Even if user sees some old profile pic, this is fine. Need not have to be immediately updated. But for bank accounts, maybe this is very important. So they will bring down the server. They'll say, okay, system is not available. And they will sync the data. Generally, it happens during quarter closers and monthly closers. They used to do this so that the consistency is important for them, right?
Yeah.
This is what is the CAP theorem.
Got it.
Sir, but if everything is means happy path, all three we are getting, right?
Yes, yes.
If-
Happy part, happy. You know, partitioning is when there is disconnection, right? So yes, in that case, you are not getting disconnection. Yes. Right. So this is disconnection.
Okay.
Yes. So you just have to understand. See, the disconnection is sometimes not in your control. Yeah, because of network connection, network is generally internet connection. So you cannot guarantee this. So you have to either design for consistency, you have to either design for availability.
Yeah, I have. Can we say like this? In case of some failure in the connection, either of availability or consistency will be there.
Yes, yes, absolutely, absolutely. This is absolutely right, simplified explanation of this theorem. Correct. So this is right understanding, absolutely right understanding. This is what you need to understand while doing system design. That's all. Nothing more, nothing less. Correct. Is everyone clear with this? I see few yeses. Yes, but yeah, anyone having any small doubt, please let me know. Because you have to be clear with this, that in case there is partitioning, which may happen, you have to either design for consistency or you have to design for availability, right? These are the two things. You have always two choices. Now let's come to system design of TinyURL. If this is understood well, then we can start doing system design. And do recall, I gave you a template last time, how to do system design, how to approach the system design. So now we are exactly in the middle of this session. We will end the conceptual part, but now we will do a kind of live problem solving of a system design, which is system design of TinyURL. Who can design TinyURL? Anyone, please raise hand and or just he can kind of start telling the solution. Assume I am the interviewer. Arun, yes, good, very nice. I see you want to take this call. So now I am the interviewer, you are the interviewee. I asked you the question, design TinyURL. How will you approach? Now your time starts now. Tell me.
Firstly, I will gather the requirements.
Okay. Tell me, what requirements do you understand from
Yeah.
TinyURL?
Yeah, the requirement is we have to create for the given actual URL, we need to create a TinyURL. That's the first requirement. And whenever we call with the TinyURL, it should redirect to actual URL. These are the two requirements.
Great. Given long URL, return TinyURL. Right?
Generate TinyURL.
Yes. Generate. Correct. Generate TinyURL. Right. And
Yeah.
also give it return TinyURL.
Yeah.
Right? Yeah. Generate. This is understood. And then next one is
Redirect to
right. So given TinyURL, redirect to original, right? URL or original URL, or we can call it long URL.
Yeah.
Right, because this is the same which we entered, right?
Yeah.
So given, or we can say on entering, right? In the browser TinyURL, we redirect to perfect. Okay, understood. This is nice. Yeah, this your understanding is right.
Yeah. And non-functional requirements.
Yes.
Yeah, it should be highly available.
Okay.
And eventual consistency should be fine. And
but yeah, you mean the consistency is not important.
Yeah, not compared to the availability. Availability should be high compared to the consistency.
Okay.
Yeah, and before that, I need to have some estimations.
Right. Tell me.
Yeah, number of daily active users and total number of users and number of requests, read request per day and number of write requests per day, and the other like amount of data per per request, for write request and all those things.
Yes. So just I will pause you. Just hold on here. I wanted to explain you something more.
Sure.
So you are assuming that these are the two simple requirements, right? Just verify, clarify, because TinyURL has other features also. So it's always good to clarify that can I give some custom URL, right? So this could be one more question. So you can ask this, okay, can I have some custom URL, or I have to generate a TinyURL randomly, right? Then you can ask that, do we need to store some more information, right? who stores the tiny URL, how many times the user accessing the tiny URL, till how many years or how many days this tiny URL should be there, right? Should be there for 30 days, should be there for 90 days, or it should be always there. You have to ask all these clarifying questions because it's very important.
Yeah,
You should,
got it.
because you cannot assume anything. Interviewer may want you to design a particular use case. And when you ask these clarifying questions, this shows your attention to detail. This shows your thoroughness. So it's very important because here your goal is not to design this tiny URL. Your goal is to impress the interviewer and let him believe that you are a very good architect. And very good architect and very good software developer will not proceed without getting complete requirements, right?
Yeah, got it.
So you have to ask clarifying question for functional requirement. Think about, right? So you can think about that, no, what all requirement could be there. You can ask, okay, no, is there something security related feature I need to implement? Right? Or what can I do? I can store the statistics but yes, assume now as an interviewer, I say, you may have to store it for say 90 days. There's no option for custom URL. Or you cannot edit, right? Can I edit the tiny URL? This could also be a question.
Yeah.
That I may want to edit the original URL or I may want to edit the tiny URL. You can ask few clarifying questions. Do not ask too many because time is a limit, right?
Yeah.
We still have to solve this in 1 hour.
Yeah.
Now, now coming to the non-functional requirement. You said, okay, yeah, definitely system has to be available because if your system is down, then your customers will go to some other competitor. They will not have a good experience. So availability is important here. But what else is important? Is it fine if you type the tiny URL and after a few minutes, you are getting redirected to original URL?
Yeah, consistency.
No, this is not
performance.
Yes, performance. Or we call it latency.
Yeah.
Latency should be low.
Yeah, low.
Because if redirection happens fast, this is the most important thing.
Yeah.
Availability is definitely important. Then low latency is important. What else?
Scalability.
Okay. But yes, you have to ask how many users will we be having for this application?
Yeah.
Yes. So yeah, scalability is important, but to what number of users?
Yeah.
So I will say that this application is designed for all the users around the world. And you have to ask, okay, is it available in all geographic locations? And how many users? I say there are these many users. So I want you to design, say, for, let's say, 50 million users, right?
Yeah.
50 million users. I'll write like this. This application will have 50 million users. Now, how would you design an application which is for 50 million users?
Yeah.
Right. So this is the scalability. Now, what you will do for this?
We should also assume about the write and read request, right?
Right. So assume a user is, what could be your assumptions?
For write, it will be somewhere around 10 lakhs. 10 lakhs, 1 lakh per day, and the reads are 20 million, because then
Yeah.
we will do only once, right?
Yeah. So you have to assume, see some calculations here. First thing is you say, okay, you store the tiny URLs. Okay, let's say we store the tiny URLs for 90 days. Yeah. And then you say that how many URL a user may create, but right? How many URLs a user may store, or if these many number of users are there, let's say every user is storing 100 URLs, right?
Okay.
So 50 into 100. So you will have in total 5 billion URLs, correct?
Yeah.
This is the storage you will need. Yes.
Okay.
Assume this is the total number of URLs you have, and this is what. And now when you store, these many writes will happen, right? Because you have 5 billion URLs. So you'll need these many number of writes. But how many reads will happen? Once you store the URL, how many times it will be redirected? Because the tiny URL is a website where once you generate the tiny URL, you will share it into your blogs, tweets, and in various social medias.
Yeah.
Right? So you can assume that maybe for every write, you have 100 reads.
Yeah.
Right? So ratio is 1:100.
You are assuming it for one day, the number.
So what you can assume is this is per month.
Per month. Okay.
Yes, you can assume per month that a user will be creating 100 URLs per month. Yes.
Okay.
You can assume like that. Yes.
Yeah. Reads and write, and about the data. I mean,
Right. So now what data will you be storing? So here you see, this is a read heavy system.
Yeah.
You should understand this is, see, database has various configurations. So here read heavy system, it's a read heavy system.
yes.
But yes, with this, you can decide how many transactions per second you have. Yes.
Yes.
So we have 5 million URLs writing per month, I said, right?
Yeah.
Now, what is number of writes per second? Convert it.
Oh,
Yes.
huge calculation.
No, I will tell you how to do it easily. No problem. In real interviews, you can use some help also. But yes, see,
Yeah.
I will explain you. Month has 30 days and every day has 24 hours, 60 and 60.
Yeah.
60 minutes, every hour has 60 minutes and 60 minutes, it has 60. So this is the transactions per second, right?
Yeah.
So this comes to, let's say, the per day, I will tell you, right? This number you would understand that. This is something like this, right?
Yeah.
Into 30, yeah?
Yeah.
This one you can approximate to 100K. It is 86,400. Everything is assumption here,
Yeah.
right?
Yeah.
So you don't have to be very accurate. So we can say this is 100K, right? Or
Yeah.
maybe even you can assume 30 days, or we can just assume it 50 days also. So you can just, for simplicity, make it like 5,000K or 5 million, right?
Yeah.
Right. So you have transactions, how many? 1,000 per second.
Yeah.
Transactions per second. Correct?
Yeah.
And read transaction, how many read transactions?
In 200.
200. So
Yeah.
100,000, right?
Yeah. Yeah.
100,000 read transaction. Now everyone would be thinking, what the hell we are doing with this calculation? Yeah, there are 1,000 read transaction and 100,000, 1,000 write transaction and 100,000 read transaction. But what to do with this information? Yeah, good information, good mathematics. But yes, you have to show that you have to do this mathematical calculation. See, this is simple fifth class mathematics, but you have to do this to show that you are someone who is having good analytical skills and you will make decisions based on the data. Yeah, right. I'm also getting one very good question from Shakil. But before that, I'll ask you what we will do with this information. This can help you choose the database, right? And how many database. So what you can get from this information.
No, readability purpose also, right? Somewhat.
What decision can we, how can we use this information in our system architecture? This is my question.
To plan hardware.
How many hardware, how many systems you would, how many systems you will need, right?
Yeah.
See, this comes around 10,000 or more. Yeah, no, that is, if this comes around 10,000 and more, then you need to use NoSQL database because the scale is going beyond RDBMS, relational database, SQL database. But since it is coming around 1,000 transactions, you may go with SQL database also, right? But yes, this can also imply if you have, you may use 10 SQL database also, and then use sharding and partitioning also, right? That is another approach. I can use 10 databases also. Assume this number is coming 10,000 or, right, say this comes 100,000, assume, right? So in that case, one server, yeah, once I will tell you one data, one information. See, a SQL database can have up to 5,000 write transaction per second. Again, this is depending on how complex is the writes transaction, but roughly you can assume 5,000 write transactions per second is good for one instance of SQL database. Right? So it's not that much. So we can go ahead with SQL databases. Right?
So one question. So are we choosing in the basis of read? I mean, like write, or I mean, we are choosing the database now, right? So are we taking that call on the basis of write?
Right. Okay, I'll tell you. You have to select both. You need to use both, right? Because yeah, you can get up to reads per second in database, in SQL database. 10,000 to 20,000, right? Maybe you can choose something around 20,000 per instance of data. Yeah.
Yes, thanks.
So these two information will help you determine what kind of database you use. But yes, you may use multiple instances also. You may use sharding also. Sharding means you can say for my first 1,000 users, I will divide the application into multiple systems. And based on the range, I will store the data in different databases, right? Maybe for India, I may have a different database. US, I may have a different database. And I'll use some code in the TinyURL so that I get to know where the redirect has to happen, where from the database I need to get that information, right?
Yeah, I have one doubt.
Yes, go ahead.
So this one instance, 5,000 writes per second. Are these requests, like these many requests, write requests that SQL database can handle with sharding or without sharding?
Without sharding.
Without sharding.
Yes, without sharding.
So you mean like if there are this many, let's say, when we shard, when the
Yes.
single instance do not have,
Yeah,
cannot accommodate.
if you have n shards, you can get n into n, right?
Yeah, then there should not be any limit, right? I mean,
Yes,
on the
there is
basis
no
of,
limit, no limit. But see, sharding has overhead. Sharding will make your application complex. Yes,
okay, then you mean that we should not do sharding for SQL.
we should do sharding, but when appropriate, right?
Okay.
Yes. So, but yes, see, okay, now let me give you another range. This is important. Yes. You have for NoSQL database, this could be instead of 5,000, it could be 20,000, right? But again, see, these are just rough numbers because based on how complex is the query, what is your setup, how complex is the servers, but generally you get in NoSQL these many and 100,000 read per second. This is available. This much more scalable. NoSQL database is much more scalable. So if you can use, if you don't have, see, I'll tell you, when to use sharding. NoSQL is not consistent, right? So they are not satisfying ACID property. I have to go into a lot of database details, right? Transactions. If you need transactions, then you have to use SQL databases. And then your if your read and writes are more, then you have to use sharding. Got it?
Yeah.
Clear? Still not clear.
Yeah, clear.
Yes.
I have
So
like,
you should use sharding when there is high scale, but there is another approach. You may use NoSQL databases also. This way, you may not need sharding.
okay, you mean if the transactions should comply with the ACID properties and it has to scale a lot, then we go for sharding for SQL.
Correct. Because transactions you have to take care with SQL database only. NoSQL cannot take.
Yeah.
Right?
Okay. And one more doubt coming to the sharding.
Yes.
So you are telling it's based on the number of writes and reads, right? When we do, why we do sharding, basically when one particular machine doesn't
Yes.
store all the data. Let's say we have terabytes and
Yes.
terabytes of data.
See, just hold on for this.
Okay.
We will cover sharding in the next class.
Sure. Yeah.
Right. So in
Yeah.
the coming class, we'll cover. So let's not worry about it right now. We know that, okay, there is way to use more number of servers for database, then that will increase. And how to do it, we will cover in later class.
Yeah, sure. And this can also be covered in the later, but I was doing one work in my company.
Yes.
During that time, I explored on SQL and NoSQL.
Yes.
I came to know that NoSQL is high performance and highly scalable, but it
Yes.
is not consistent. Whereas
Correct.
SQL is consistent and
Yes.
it's not very scalable, but I don't know the reason why. Like we can also cover this later, but
Yes,
yeah,
we will cover. Yes, we'll cover. You'll get to know.
yeah,
You
sure.
will get to know each and everything. Do not worry. But yes, you have to have patience, and in few classes, you will know about that. I'll share that also, right?
Yeah,
I'll
sure.
Perfect. So now we have decided this is how it will be. Can you do the API design also? Right now,
Sure.
see, you did some good calculation. You can say that, okay, since this is the read and write, I can achieve this very well with SQL databases. So I decide to choose the SQL databases, right? maybe now you proceed to do the database design and do the API design. Next step.
Yeah.
Right. So
Yeah.
let's talk about database design. What would be the database design here?
Yeah, database design, we have one table, tiny URL, table name is tiny URL, something kind of.
Correct. Yeah, you can have one table to store URLs, right? That's
Yeah.
one. And
Yeah,
you can
and it contains two fields.
yes.
One is tiny URL and
Yes.
another one is actual URL.
Yes, right.
And yeah, a tiny URL itself is a primary key.
Right. Okay, good. You can use this as an ID. ID is in URL, right? Okay.
Yeah.
So you have which is a primary key, and then you have the original URL, which is the data, right?
Yeah.
This is sufficient.
Yeah, sufficient. And I have one doubt in choosing the database.
Yes.
I see more pros compare for NoSQL compared to the SQL, because in NoSQL, if we take the database as NoSQL here, we have
Yes.
like fixed set of queries, right? Only we need like one
Yes.
particular query.
Yes.
So, and if the data is huge, like it can scale. And
Yes.
so
yes, you can use here NoSQL as well, because scale is not high, right?
yeah, and there is no relationship between other tables as well.
Yes, you don't need availability. You don't need that consistency, right?
Yeah.
Transactions. You don't need the transactions. So you can use NoSQL also. It's up to you. Whatever you feel, because there's no 100% or no one correct answer. There could be multiple correct answers also, right?
Yeah.
Okay. Yes, the sharding part we will cover. So do not worry about sharding. I see many people are not aware of sharding. So that's why I'm postponing this discussion, but we will cover this, and we need to cover some more database concepts for that. But yeah, do not worry. So we'll not go through the sharding, is not applicable here. So yes, go ahead. Now, do the API design. See, database design is very simple. Do the API design.
Yeah. Create tiny URL.
Okay. Say create tiny URL is your API. Okay.
Yeah, and it takes the parameter of actual URI, actual URL.
Yes.
And returns the responses to success or failure.
Okay, create, but it should also return the tiny URL, right?
Yeah.
It should return tiny URL.
Tiny URL,
right?
yes. Yeah.
In case of failure, it may return some error code or yes.
Yeah.
But yes, in case of success, it should return URL.
Yeah.
Okay.
Yeah.
How about the other API?
Redirect, get.
Yes, you can have the get
actual URL.
Yes, get original URL. So see, simple. This is how you will have to do. And input is you will take tiny URL, right?
Yeah.
And what it will do, it will redirect to the original URL, right? Maybe you can have some function which return you the URL, and maybe you can have a redirect function also, right?
Yeah.
Which will redirect, which will be void, right? Because it's actually doing the redirection. Yes. So this you can give, yeah. So you what have to do to redirect to the long URL, right? Yes, correct. Something like this. Got it?
Yeah.
So this is your API design. This is your database design also. Now, talk about the system architecture. What components would you need? Right. So you'll need, see, a client to make a call. You'll have a UI where you will add the long URL and you will have make the call by clicking on submit. What will happen next?
Next, we should have application servers.
Okay. How will you have, yes, See,
multiple
you
application
have-
servers.
Yeah. How many application server you have?
I'm not sure of one application, how many transactions will happen.
Yes. Yes. Right. Right. Correct. Okay.
So if I assume like one handles 1,000,
Yes.
then it should be somewhere around
Yeah. You
20.
can assume one application server can take up to 10K requests
10K.
per second. Right.
Okay.
Yeah, this is our
25.
application server.
We should have 3 then,
Okay. Okay.
and we should have a load balancer in between client and
Yes. Right.
server applications.
Okay. Yes, so you have a load balancer, right? And then you have multiple application server. Exact
Yeah.
number does not matter because again, depending on what is the power of the server, but you will have multiple. That's what you have to say. Interviewer is not interested because exact number will depend on the environment, how you have implemented it. So all that detail not required, but yeah, you will have load balancer and application server, right?
Yeah.
And what else?
We will have again a set of databases, and here we should also have a load balancer between the application server and databases, right?
Yes, you can have if you are using cluster of databases, right?
Yeah.
You can have a load balancer here also, database. But yeah, see, this many of the databases comes up with inbuilt load balancer. So need not have to talk about this part because database server is a lot of times they come with the load balancer inbuilt.
Okay.
Yes. So you can have this. See, there is a problem in this design. Tell me what is the problem? Is it microservice architecture or is it monolith architecture? You have two main APIs, right? This or three APIs we have actually.
3.
So what you will have all the code in this application server,
Yeah.
or you can have different application server for different APIs.
No, we will all the APIs will be in one application server.
Why?
It's all related to like one particular
Yeah, but see, if you put this API in one server, let's say we have one set of servers for read application server, other one is write application server, right? So you will have here multiple instances of this. So just a minute, let me get this.
Sir,
What
how do
is more, read or write?
read is more.
Right? Yes. So this way, you will be able to scale better read because you may put more servers here in the read, and in write, you may put less servers.
Yeah.
You get flexibility and better scalability also.
Yeah. Then how can we route based on the the call will come?
Yes. Based on the call, you can route. Say, assume this is called by post method, right? You may have, say, some REST API. We will cover about REST also in detail. But yes, how will you make a call? You will make a HTTP call, right? HTTP, or we can call REST call. And there could be, say, one call like for this, right? You will say, yeah, something, create. So when you put, I'll put link because URL is sometimes sometimes keyword, right? So like this is the post request, right?
Yeah.
So, or sometimes you may get a call like for this. Right, something like this, or short URL or tiny URL. Yeah.
Yeah.
So if you get this call, load balancer can route to the right server. If you get this call, load balancer can write to read server, right?
Yeah, one doubt here. The load balancer is useful for distributing the load based
Yes.
based on the round robin
Yes.
or like
Right.
lowest and all those things. But is it also used for distributing the traffic based on the API call?
Yes, yes, absolutely, absolutely. You can do that in the load balancer. Or to be very specific, you have proxy server, right? So again, there are two kinds of proxies, reverse proxy and forward proxy. So you will use a reverse proxy,
Okay.
which can do this. But yes, load balancer also have this feature. Based on the request, it can direct it. It can act as a proxy, reverse proxy also, right? We'll cover again what is reverse proxy in the next few classes. But yes, a load balancer can do this.
Sir, I got it out there. So, I mean,
Is it
how do
API gateway? Maybe we can say API gateway.
Okay. Yeah, API gateways and all we'll cover. Yeah, API gateway can also do this. Awesome. Yes, this is right. But we may use API gateway also, which is also a load balancer, proxy, caching, lot of other things you will get. Right. Nice, nice. But see here, there's one more problem still in the design.
Read separate database and write separate database.
Okay, that's fine. Yeah, databases will also have multiple clusters here. That's correct. Because, yeah, you may use master slave architecture, right? You write to masters. This is master. And you don't call it like microservice. This is a master slave architecture, right? You'll have many slaves. But yes, for others, please note down all this. And we will be covering and we'll be going in depth in later classes also. So it's not that if you do not understand this class is over, so that and everything is over. We can always keep revisiting this. But yes, you should understand master slave. But when I will be covering all these topics, master slave architecture, I'll again refer back the same design and I'll help you understand this in more detail, right? But here you should understand master is the instance where write operation happens. And slave is the instance where read operation is happening. And every time you make any update, all the copies will happen automatically to all the slaves, right? So master will have connection to all the reads and it will copy the data to all the slaves. And whenever there is a read request which is coming, it will be done from multiple slaves. You have only one master. Here, you may have many slaves. Say 10 slaves, or maybe we can keep say 5 slaves, right? Because we see that this from these numbers, we can say that, okay, one master is enough. And maybe more slaves you need because this was 100,000 read 5, right? This.
what if the master itself fails?
Master fails, then one of the slaves can be promoted as a master.
Okay.
Yes. So yeah, then you may have few more mask, maybe 6, 7. Yeah, you can have 5 to 7 slaves, because if some slaves fail or some master or a master fails, then you make one other instance. A slave could be automatically promoted to master,
Okay.
right? And
And one more doubt I got. I mean, in the application servers, we understand that it's 10K requests per second. So how do we understand, I mean, the number of application service that is required? How do we calculate?
yes, I gave this number. 10K request per second is for application servers.
I mean, how do we get that number? Should we ask
Yeah.
the interviewer itself or
Yeah, you can ask and you can just check. I'm making this assumption. Is this reasonable? You can check with the interviewer.
Yeah,
Right?
yeah, Naveen, I got your doubt. So we have 10K per server, right? And total transactions, we have the calculation in the left side. So total reads plus writes. So total there are like per second, it can have 25,000 requests, right? And here we have 10K. So 25,000 divided by 10K, then we can get the number of servers.
Yes.
Okay.
Right. But see, again, no, the exact number of requests per second, how much, it depends on what kind of processing is required by the server. Right. So this is an assumption. So whether you are putting exact number does not matter here. Got it? You just need to say that there are multiple servers. But yeah, you can take this assumption and say, based on this assumption, this is the number. Right?
Okay, got it.
Correct. But I'm saying that it's optional. It's up to you. You may say, you may not say. But I would say, in case interviewer asks, then you can use this calculation, but need not have to do that calculation. You can just put that there will be multiple servers. That's all. Right? Great. Yes, I will export this notes as a PDF and share, right? Whatever I'm writing here, I'll put this as notes, but be very understanding is very important, because if you are understanding it well, then you don't need the notes, right? But yes, I'll be sharing this notes for your reference. Okay.
And can you also share the document that was the basic document for system design, the checklist?
Yes, sure. I'll share, I'll upload all these things. Perfect. Yes. So yes, now I still see there is a problem in this design. You guys should also be seeing it, but you are not paying attention to that, because you have to ensure each and everything which we discussed has to be, is this highly available? Yes, correct. Because you have multiple instances of servers. Some servers goes down, others will be there. So it is highly available. You have load balancer. Is it scalable? Yes, it is. Correct? Or is not? No answers? Load balancer can also fail, but it is highly unlikely. So yes, I got a question from Ramesh. This is good question. The most common setup of load balancer is you use active passive setup, right? Where you have one for in case the first one fails, and that is enough, right? Active passive. So if one fails, then you can use the switch to the other one. And otherwise, yeah, you just need two load balancer, active passive, one as a backup load balancer. Awesome. Nice question. Nice question. Great. But yes, even one very important thing is missing. You will not get this low latency. You are making a call to the database. Database will do a query. And there are So many URL, 5 billion URL. Getting
Cache.
yes. Caching is required. Yes, otherwise your site will be slow and redirection will take a lot of time. So you don't need to call directly the database. You need to call cache. What should be the cache size? Anyone? What will be the caching strategy? How will you cache? What information you will cache? What happened? Silence. Silence
More
in
freq-
an interview means you are stuck. Interviewer will
More-
note down
Have
that
you?
the
more frequent read operations.
yes, most frequently. Okay, that's you can use, or most recently also you can use. Yeah, most frequently you can use. So you need to tell two things about caching strategy. Cache eviction policy, right? Because when you will have the cache filled up, what data you will clean? So you can clean the lowest frequently read URL, correct?
Yeah. Is it a write through cache or write around cache?
What when you have to decide?
It should be right around because we don't update, right?
Yes, yes, right, sure. So least recently used. Yes. Right, see, you can use write through also or write around as well. Here, if you use write through, that means you write to the cache and write to the database at the same time. In write, if it takes little bit more time, is fine, right? Not that important.
Yeah.
In read, anyway, read does not matter whether you use write through or write, right? So yes, you can use any of these. Does not matter in this case because write performance is not that critical. Low latency is for the read part. Yeah, but it's good to have for write also low latency. So if you want that, you may use write ahead, right?
Yeah, but right here the right means creation or updation because
Right means updation. Yes.
updation we don't do update, right? Here there is
Creation. For creation, yes, you will do creation, right?
but if we do creation then it should
Correct.
be
Absolutely.
like it should be most recent I mean the cache we are eviction
Yeah, it
policy we
depends
are
on the reading. Yeah, if it's not read, then anyway, the cache need not have to be updated. Yes, this is also very good point. Most of the writes when you will be doing, the data will not be there in the cache itself.
yeah.
Correct, because
Yeah.
create, you are always doing create. So yeah, you can use any approach. It does not matter because you will be writing to the database. Okay, yeah. So what could be done is caching is required probably for the read part only, right? This part. Writing part, you can directly write to the database. Nice. Sorry, this is write will happen here, read will happen here, right? Okay, I should have drawn this side, drawn that side, right? Clear?
We'll be covering these cache principles in the later point.
We'll be covering caching in the later classes. About what are different kinds of caching, what to cache, what not to cache. Basically, here cache size should be 80-20 principle. Right? So 20% should be the cache size. But what is the database size? We did not calculate it. How many GBs of database you need? What would be one row? Maybe hardly
100.
500 characters, right? You'll have here in one row. Yes.
Yeah.
ID is a small tiny URL, could be 7 or 8 characters or even lesser also. We'll go through this calculation in the next class, right? Because in the next class, we will implement it. We'll go through the low level design. So do not worry. You can go through this design and think about the doubts, but we did the high level design. Most of the interviews will be around high level design. In 1 hour, you have to design this tiny URL, and I have shown you exactly this process. And the exact same way you have to discuss, and you don't have to miss out anything. Cache, for example, here we missed out. We should not in the real interview, right? You have to come up with that there is a cache required. And yes, you can share all these details which I'm giving. This will give an understanding to interviewer that you understand it well and you have practical experience in working with distributed systems, right? So here we say 500 characters. 500 characters means maybe 0.5K kilobytes of data, right? And we have how many URLs to store? We have 5 billion URLs to store, right? We got this, right? Every month we will be storing 5 billion URL, right? So even if you have these many, but yes, if you have, say, this application running for 5 years, you have 60, right? Months. So probably 300 billion URLs, right? If we design for 5 years. Because maybe after 5 years, you may flash the information, or we are doing it in 90 days. So in that case, even 3 months is good enough. But yeah, if it is 5 years also, no problem. If it is 90 days, then you have 15 billion URL, right? URLs. And for 15 billion rows, basically, rows as well. And every row is, right? So this is how much?
7.5 billion KB.
Yeah, what is billion KB? Yes. Correct. Is called petabyte, terabyte, what? Gigabyte, terabyte. Yes.
Okay.
Great.
Yeah.
Right. And nowadays, 1 terabyte is there in one computer. So not a big deal, right? This information is also not a big deal. You may get a single hard disk of that size, right? We can get 10 terabyte hard disk, right, in the market. So not a big deal. But yes, you need to replicate it also, backup. backup also you would be taking. Maybe if you are taking 2 backups, still it is around less than 25 terabytes, right? This much is the data. See, data also matters, because if the data is coming in the data is coming in petabytes, too much of data is coming, then you need to use sharding, or you need to use NoSQL databases. NoSQL database can deal with large amount of data as well. Yes.
Yeah.
Now my rule is, I give this rule that if you have billions of rows, right? In this case, you are seeing we are getting billions of rows. You need to index, right, your database. But indexing will become very slow if you have billions of rows. So you can consider here NoSQL database. It's slightly better. Right?
Yeah.
Or sharding also, you can use sharding also. We'll cover it in the next class.
Could you repeat that last point? Here, if you are doing indexing for the SQL, it will become slow. But so we have to go with NoSQL. That is what you told.
Yes, yes, absolutely. For billions of rows, right? Billions of rows, if you are doing indexing, and when you are writing information, index need to be updated. Yes.
Yeah.
So indexing becomes an overhead for these many records.
Okay. And we are also having the indexing concept for NoSQL, right?
In NoSQL,
Yeah.
in NoSQL, yeah, you have in different kinds of NoSQLs are there,
Yeah.
MongoDB and all. So we can cover that in later classes, that how to, not all NoSQL databases will have indexing, but yes, document database, there is different kind of indexes available in different kind of NoSQL databases. But yes, you don't need indexing in NoSQL databases. It is automatically indexed. But in relational databases, you have to define the indexes. In NoSQL database, there is no schema at all, right? So it is all automatically indexed, and schema is also determined automatically. But yes, something similar concept is there. I'll share in the class when we will be covering NoSQL databases.
Yeah, sure. But I have like confused because we are not choosing SQL because of the indexing. And in NoSQL, it's we are having multiple indexes for every field, and still the indexing is there in NoSQL, right? It will be more complicated, right? Than in NoSQL.
No, it is not complicated. It is easier in NoSQL, right? So here you take it this way. See, you have lot of rows, right? But yeah, you may, so let me tell you that since you have a cache, right? Cache could be a NoSQL database, right? It could be something like Redis cache, right? So this way you can deal with the with SQL database also. You can have a combination of SQL and NoSQL databases in this case. And with cache, you will be able to read operations will happen from the cache, right? Always, most of the read operations will happen through the cache. So you may not need the indexing here also. Got it?
Still not very clear about the indexing. So the indexing
Yes.
strategy in SQL and NoSQL are different or the same?
Yes.
Like,
So let's just talk about SQL.
okay.
Right? First, we will talk about SQL. Index is what? Index is the order of rows, right? It will be a separate data structure which will keep track of rows. It helps in finding a particular row quickly.
Yes, B plus tree.
Right.
Yeah.
And when you insert any record, the indexing will make the writing little bit slower because it will create the index as well for the new record.
Yeah.
Yes.
Yeah.
And when reading, index will have a lot of information. With reading, it will be faster, right? Only writing may take a lot of time. Yes. And actually re-indexing and all we will cover, then you will be clear with this. But yes, if you don't use the index, then no problem. Right? Because the volume is not that big, terabytes. Yes. Right? Do we need an index here? That is the question.
Yes, we need, right? For primary key is also indexed.
Okay. Yes. Correct. Good point. Yes. So you need the index. And index becomes slow. Writing may become slow. Yes.
Yes.
Because reading, we are anyway having cache. So no problem. You are whatever you are accessing, you are getting. So initially, maybe first request when there is no cache, that will be slow, but later it will be faster. So if you use NoSQL, there's no need to index. Right? It can handle large, you can think of NoSQL can handle large number of rows and it can even index that also properly.
Yeah, this is where I am confusing. So you are telling it can index, NoSQL can index.
Yes.
So the indexing the NoSQL does is same as the indexing SQL does.
No, different.
Different.
The database is completely different. Right.
Okay.
So how it does, I will cover in the class when we will be going in depth of NoSQL database. But for you, for now, just understand that problem which we have with indexing in SQL database is not there in NoSQL database.
Sure.
Right?
Yeah.
Can you understand that much?
Yeah, I understood.
Right. See, NoSQL database can handle large volume of data. How it handles, we will cover in the later classes.
Sure.
Right? And in that also, we will cover when to use NoSQL, when to use SQL, because that is very important thing, right? But
Sure.
here, yes, again, I would say that in both these cases, whether you say SQL, NoSQL, not that big problem. But yes, here, this problem you have to focus on that you need to use a cache.
Yeah. Got it.
Right. And then you need to use microservice architecture, read and write separately.
Yeah.
Right. If you do that, this is decent answer. You will get good feedback. You will get strong, higher feedback for system design interview. If you do all that hard work, see, systematic approach is required. Final solution is not that important. Your approach is important. So you demonstrate that you have followed a very thorough approach. You have designed APIs, you have designed database, you did this calculation, you put functional requirement, you put non-functional requirement, you clarified them well before diving into the architecture. And architecture is based on calculation, based on database, based on this numbers rather than some bias or some vague assumption. So you will get best feedback in this. right?
Yeah.
Great. So next time I'll ask today very few people were participating, but yes, I would appreciate if more people can participate in the same time. And in the next class, we will continue with this. We'll continue into the low level design of TinyURL, right? So be ready with writing the code for read and write for this application, right? So we'll be writing the code in the next class.
Sir, can you also share the course modules? I mean, like if you have a structure, like, what all things will be covering, like a standard syllabus. I mean, like the syllabus that you're following, that can be shared.
Yes, I will share you the content, right?
Correct.
Content I'll share you. Definitely.
And I mean, this course will be there for like 2 months or 3 months. I mean, how many classes
It will
will be there?
be 25 classes.
25 classes. And
Yes, 3
the three
classes
days?
per week. So you decide, figure out how many. So,
Sure. Okay.
right. So,
Hello, sir.
yes, tell me.
In the next class, are we going to discuss about the SQL, NoSQL indexing cache? Because as I'm from
Yeah.
a new, as it is a new background for me, to be
Yes.
honest, I'm not able to grasp the concepts
Right.
which people are discussing. So
Right.
I think, yeah. So should we have to possess any prerequisite before doing this design?
But yes, how much, again, maybe I'll ask the same question. How much percentage you guys understood? Please write down. Yeah, please put in the comments how many percentage you understood. Write 0 if you do not understood anything, or write 90, 95 or whatever. 60, 10, 50, 20, whatever is your number, right? Yes. See, system design is a vast topic. I understand you will not understand everything in first day, but gradually you will understand, right? So this you should always be comfortable with, that in one day I can't make everyone a good architect. No one can make you perfect architect in one day, but in maybe 2 months, I will definitely be making you excellent architect, right? Because we will be engaging in all these discussion. We'll be going through good problem solving, good number of problem solving. So you will in few classes understand all the concepts. But yes, I'll try to cover in the next class most of the concepts which were discussed in this, right? So we will cover that. I'll make sure that you feel more comfortable in the next class. So we will revisit TinyURL architecture, and we will then go through the low level design of TinyURL.
Thank you, sir.
Right, correct. Okay, so today cap theorem you all understood?
Yes, sir.
Yes, sir. Yeah,
Right?
it was good.
Great. So we will cover that.
Yeah, sir. Actually, what you said was I can understand it, but there are some terms, like
Yes.
cache indexing. This was very new for me.
Yes.
Yeah.
We'll cover that. We'll cover that in next class, because now when it is coming up, you will be in a better situation to understand it, because now you are seeing where it is applying. So we'll cover that next class. Great.
Sir, are we going to do practical coding in this
Next
series?
class, in the next class, yes.
Okay.
But in high level design, no coding. Low level design, definitely coding.
Okay, sir.
Yes, because high level is about this database, choosing application server, how systems are connected, all that. But low level design will involve coding. So next class, we will be coding here the read application server, write application server.
Okay, sir. Okay.
Great. Awesome. See you.
Thank you, sir.
Great.
Thank you, sir.
I'll close the session. See you in the next class.